division problem, there are 4 parts that we have. We have the dividend, which is the number that's going to be divided. Okay? We got to make sure if you have a division problem that's written in a number sentence, make sure we understand that this is the number getting divided. Okay, so this is our dividend. We have our divisor. That is the number that we're dividing by. Now, when we divide, 8 goes into 35 how many times? 4. That 4 goes up here. This is our quotient. 4 times 5 is 32. Subtract, you get 3. And that 3 is our remainder. Today we're going to talk about what are the options that we can do with our remainder. There are basically 4 things that we can do with our remainder. The first thing, what is the first option you guys always did with the remainder?
You just put an R number.
Write it as a remainder. What's another option you can do with the remainder? Wyatt?
Can't you write it as a decimal?
A decimal or a fraction. What's another option we can do with our remainder? Landon?
Isn't there a way that you can keep going and you put a 0 down?
Well, that's what Wyatt says as far as putting it as a decimal or a fraction. Another option is to drop the remainder and the fourth option,
Round it?
make the quotient 1 bigger. So there's basically 4 options that we're going to have when it comes to deciding what to do with the remainder. Now, when do you think we're going to write it as a remainder?
Like if it asks you, like how many will be left or something?
How many are left? If it asks you the question, how many are left, that would be when we would write it as a remainder. How about, when do we write it as a fraction? Give me an example of when we would write the remainder as a fraction.
When we're dividing with decimals?
If we are writing with decimals, yes, they're going to want you to continue writing it out as a decimal. That is true. When else would we want to write it as a fraction?
Word, like the problems, the word problems, where it's negative percentages.
If it tells you to write it as a fraction,
Like when you're dividing and it has a fraction in it.
possibly. How about this? If it tells you that you must use all of something. If it says we're going to use all of something, everything, all of it gets used, Well, then we're going to write it as a fraction, whatever's left over. What about dropping the remainder?
How many they will need?
How many they will need? Okay. That's more of a multiplication problem, though. Why?
When rounding.
No? Because then we put that, making it one bigger. We would drop the remainder if everybody gets the same amount. Then when would we make the quotient one bigger? Anybody give me an example when we'd make the quotient one bigger?
If it actually surrounds with like numbers.
If it tells you to.
When the remainder is higher than.
Not necessarily. How about if you're asked for a number of tables needed? If you're at a banquet and you need 6 tables, but you have 2 people left over, does that mean that those 2 people don't get to eat? No, you're going to set up another table, right? So you're going to make the quotient one bigger. Okay? So, these are the 4 things that you're going to need to do to decide what to do with the remainder. Okay? Now, let's make up a word problem of when we would use the remainder. Can someone think of a word problem in which we would write the remainder as the remainder? An example? You've only dealt with these all your life, and it comes to this, and put you on the spot. And oh gosh, when do we use it? Yeah, just make a word problem. Johnny?
Jason added 60. Well, Jason invited 63 people at a party. But ate more one at a time.
No, but that wouldn't be a remainder. Landon.
Jose has 18 jalapenos, and it takes 7 jalapenos to make salsa. And how many containers of salsa are left? I mean, how many containers
Okay,
of
so-
salsa can you make?
How instead of saying jalapenos, we'll say peppers.
Okay.
Since Landon came up with Landon has, you said 17 peppers.
18.
I made it 17. I forgot what you said. So Landon has 17 peppers. He needs 5 peppers, I don't know what you said, to make a container. How many containers can he make? How many are left over? Would you agree with that?
I guess.
Yeah, because it's asking how many are left over. What is the remainder? How about for a word problem of when we're going to write the remainder as a fraction?
How do you say me? Alright.
No one in here.
Okay. Daisy has 1 and 10.
Anybody? How about this, since Owen spoke up? Owen used 15 yards of fabric to make 6 hats. Okay? He used 15 yards to make 6 hats. How many yards of fabric did he need for each hat? Because it says he used 15 yards. He used it all. There was nothing left there. He used it all. So in this situation, we would take 15 divided by 6 goes into 15 2 times. That's 12. Subtract, get 3. That 3 is your numerator. Denominator is 6. We can reduce it. Divide it by 3, giving you 2 1/2. And so he would use 2 1/2 yards of fabric for each hat. How about dropping the remainder? Anybody think of an example of when you would drop the remainder? Give me a word problem.
When you say drop the remainder, does that mean just don't even?
Don't use it.
Okay, so Elmo has.
Alright? My daughter will love you. She loves Elmo. Go ahead.
10 crayons,
Okay?
and it takes 3 crayons to make up a box of crayons.
Okay?
Elmo wants to know how many boxes of crayons he can make.
How many bucks? Good. So Elmo has 10 crayons. He puts 3 in a box. How many full boxes can he make? Good. Okay, because it would take 10 divided by 3. 3 goes into 10 3 times. Subtract, you have 1. Well, we can't make another box without 1 crayon, right? So we would be able to make 3 boxes. And the last one, making the quotient 1 bigger. Give me a word problem in which we'd make the quotient 1 bigger. Dakota?
Lily has 13 pies. She wants an wait no.
Okay. Alyssa?
Emily is inviting people to her party. She has 13 cupcakes, but she wants to invite 15 people.
Dang. Yes. Landon.
Okay. Big Bird has a party on Sesame Street,
Okay.
and
I see a theme here.
78 people coming, and he got 6 tables that hold 9.
How about we do this? Who was it? Big Bird.
Yeah, Big Bird.
Okay. So Big Bird. How about at Big Bird's birthday? There were 76 people. Okay? 5 people can sit at a table. How many tables do they need? Okay? Because we take the 76 people, we put 5 at each one, at each table. 5 goes into 7 one time. 1 times 5 is 5. Subtracting it 2. Bring down to 6. 5 goes into 26. 5 times 5 is 25. Subtracting it 1. But we're going to have to send that one person home.
Yeah.
Sorry, it's you, Wyatt. You're going home. You don't get to eat. Okay? So, instead of having 15 tables, we're going to make this one bigger. And we're going to have 16 tables. Now, did we have 16 tables just because there's one person left over? We would have needed 16 tables if there were 2 people left over, right? We would have needed 16 tables if there were 3 people left over. We would have needed 16 tables if there were 4 people left over. Okay? Just because there's one person left over, that's not why we added by 1. It's because we needed 1 more table. Okay? Any questions? That's what we're going to be working on today, is deciding what to do with the remainder. We're going to write it as a remainder to tell us to use it, or we're going to write it as a fraction, meaning that everything that's getting broken up, all of it must get used. Or we're going to drop the remainder. Well, we're having a birthday, and we have 24 pieces of candy, and there's 5 people there. And you can't break the candy up. And you have 4 pieces left over. Is it fair for 4 people to get an extra piece and 1 person not? No. Okay. So we would drop the remainder. Okay. Make the equation bigger. The easiest one is the tables. Okay. We're putting tables down. If you have some people left over, you need to make 1 more table so that they have a place to sit. Okay. Any questions? All right. Question, Owen.
Well, if